Good morning, everyone. Today, on the phase 3 of the coursework of Ph.D., we have Dr. Girin Baxi with us. He's the head of chemistry department. So, on behalf of all the chemistry and geology and other science students, we welcome Baxi, sir.
Thank you for your kind welcome. Due to some reasons, I am not able to show myself on the camera. There is some setting change, but can you hear me?
Yes, sir. You are completely audible, sir.
Okay, fine. So, well, I will just take this opportunity to thank the Research and Development Department of the university to invite me for this lecture. I'm really happy that there is the number of participants is more than 20 at present. And I hope in science faculty, there are a good number of new scholars coming up to give some new horizons to the faculty of science. The first thing is, I hope those who have registered, they have got a goal that why they want a PhD degree, right? Why they want a PhD degree? Because sometimes it happens that there is a degree with some motive. Say for academic line persons, they want it for their promotion. For industry persons, they want it for their more and more research output to serve the mankind. So in each and every field, whether it is mathematics, statistics, physics, geology, environment, everybody is having one or the other motive of becoming PhD. So I congratulate all of you to select this highest degree of education so far. But at the same time, I would wish that all of you should make the best advantage of this. Because it also happens sometimes that he or she is my friend, he or she has completed MSc or MA or MCom, whatever it is. Now he or she is going for PhD. Let me also go for that without knowing what is PhD. Of course, at the PG level, what is PhD is not known, is not possible. Everybody would be knowing that. So I was in touch with the previous coursework schedules, and I found that it was possible that many of you would have got some repeated topics. Obviously, that is sure. And so the first question with all those topics would have been, what is research? I am not going to ask you that because all of you are almost saturated with this. So I'll definitely directly go with my topic itself, which I have selected as research and science. And to be very honest, there are a few points which I have put in my way. There are few points which I have searched on net how to explain. And I hope they can be helpful to you. So let me try to share my presentation, because it is very clear that without that we cannot go ahead. So first thing, please let me know whether it is a full screen or a partial screen, because I am unaware of this. Can you see, everybody, can you see this?
It's a full screen, sir.
Okay, fine. That is good. So now let me go ahead with it. With this, you have been already introduced to what I am, who am I. Let us go to the next presentation. Are you able to still visualize this, all of you?
Yes, sir. It is completely visible.
Okay, so now let us go to research attitude, which I want to express, in the sense that, as I told you, what actually is idea behind you to go for research? Because it sometimes happens that even after getting that PhD degree, few of the new degree holders don't know how to write PhD. And in that case, it is very questionable that there was no goal, or there was no aim, or there was no reason of going to PhD, to go for research. So all of you, please, please, please keep this thing in mind. You, whenever you complete your research work, your viva, and you are given the degree, you should write it properly. It should be P capital, then H small, full stop, D capital. I'm sorry because this is not the way to discuss, but I have already seen many people writing all three letters in capital, with full stop between each letters. So this is questionable. So if you have gone through a lot of work, lot of labor behind completing your work, at least the final thing should be proper. Of course, with my experience, if I go, I completed my PhD in 1992 when I was in Lalan College as a lecturer, and I had completed that. And so from Lalan College, when I went to Jamnagar in 1994 and I got transferred, in the very first month, I got one of my neighbors coming to me because my nameplate already had Dr. Girin Bakshi. One of my neighbors came to me and told me, બાજુમાં અમારા રિલેટિવ એક્સપાયર થઈ ગયા છે, અમને ડેથ સર્ટિફિકેટ જોઈએ છે. Now this is I would say illiteracy or lack of knowledge. Now of course many are there. Then I decided, let me not write doctor every time, because that creates a problem. But of course, this degree is such a magical degree, I would say. It's such a good one that we obviously would prefer that we should be a doctor. But the society accepts doctor as the one who treats the patient. But so far as my subject, chemistry, goes, we give some new drugs to the industries to give you a chance to serve the mankind. Okay, so let us go ahead. Research becomes that pursuit of knowledge. It is one kind of shadow. Through the process of discovery, you are going to find out something. And then our topic is, our faculty is science. And so I will always stress and emphasize and say more and more about these things, that scientific research will involve diligent inquiry, a big depth of the inquiry. Then there will be a systematic observation of the phenomena, and whatever projects come in our way, these projects, when it comes to science faculty, they will not be without experiment. So they will be involving experimentation. They will involve some testing the effect of changing conditions on the results. Because when we are putting up something new, what is required is there should be sufficient evidence, sufficient documents that whatever we have done is fine. And another thing, once you get this degree, please see that your career should be according to that. Unfortunately, there are many instances that those who are PhD degree holders, but still they are government teachers in primary schools or secondary schools. Try to go ahead in the appropriate way. So scientific research will always go for experimentation. Then the conditions under which the specific observations are made must be carefully controlled. Now, suppose research can be of any kind. Research, you can say, it can be of any topic. In fact, for science, we are having many. I'll be going to some topics in the coming slides, like when I'll deal with the different subjects also. I'll cover not only my subject, but many. So all the observations should be very much careful. And I'll be putting some Gujarati words inside so that those of you may not be so proper or comfortable with English can go to that. They must be carefully controlled, and records must be meticulously maintained. There should be a system of maintaining the records. Now, you can go for anything. When you come across this particular okay, I've got a question somewhere. Is this slide changing?
No, sir.
Sir, it is still on the first slide.
Okay, so I'll have to go in a different manner probably.
Yes, sir. Now it is changed.
No.
Now it is changed, sir.
Actually, I wanted to go for full screen, but that is not possible. Okay, so now I'll go with this, and I hope you can probably read it properly, right?
Yes, sir, we can read it
Okay,
properly.
right,
Yes.
right. So the conditions, see, in the previous coursework lectures or even during your studies in MSc, if at all you come across what is research methodology, you would have found that there is a big requirement of a data collection. Research again becomes something new. You take some good examples of even food items. Previously, what kind of food or sweets were available? The same are available with some modifications now. You can go for drinks also, soft drinks. Modifications are coming. Previously, there were only 300 ml bottles. Now we are having even 100 ml bottles or 200 ml bottles, or even 500 and 1 liter bottles. So this is again some research. So there should be a observation that if I give for 5 persons 300 ml bottles, it is becoming very difficult for them to drink properly. So what I have come with is I'll come with one 750 ml bottle. So it will be 150 ml to each, so that is better. Or I may go for 1 liter bottle. It will be 200 ml for each. So what has happened? Your observation, which was there, a careful observation which was there, that 300 ml was going to be too much for everybody to take. So you came down with, now if you want to prepare 200 ml bottles, 250 ml bottles, it's very difficult. So I came out with plastic bottles. I come up with something different. I've come down with the rates so that you can afford it. So all these observations and records should be properly maintained. This ensures that observations and results can be reproduced. Scientific research can be basic also, which is also known as fundamental or even applied. Now, these two words we have already discussed you would have already come across in your previous sessions, but still, let us just highlight what becomes the difference between the basic or the applied part. So the basic one is, the objective of basic research is to gain more comprehensive, that is generalized knowledge, or understanding the subject under study without specific applications in mind. No specific applications we are applying. Say in industry, when we talk about basic research, we find that it is a research which advances scientific knowledge but does not have specific immediate commercial objective. Now, suppose you are producing something. Say, suppose there is an industry which is producing soap. So, once you start that particular process, you are not directly through to the products. It will take different steps to reach to the product. So, there is no specific immediate commercial objective. આપણે પહેલા બનાવીએ અને પછી એમ લાગે કે આ ખરેખર બધાને પોસાય એમ છે, સુગંધ ગમે એમ છે. Only then we can go ahead. Of course, it may be in many fields of present or potential commercial interest. But still, once you get proper results or till you don't get proper results, I think we are not going to be so specific with that. Applied research, it is aimed at gaining knowledge or understanding to determine the means by which a specific recognized need may be met. I want certain soap which should not have too much flavor inside that. If I get a more flavored soap, my nostrils will get affected. I may be attacked by an allergen and I will face a problem. I'll start sneezing. And what happens? What has happened? With that first use itself of the soap, you have rejected it. So, applied research has to be aimed at gaining the knowledge or to determine the means by which a specific recognized need may be met. We should come up with such a product that it should be applicable properly to all. In industry, applied research will include investigations oriented to discovering new scientific knowledge. When you go to an industry for some production, what you actually want is, we want to discover something new. Science knowledge which we have to use, or the science knowledge which is available elsewhere, from where we can get the information is available and which we can prepare something new. So what has happened? That has got specific commercial objectives. I want to deal with this with respect to products, processes, or even services. Now, we are generally talking about research after post-graduation. And that is our conventional pattern so far. 10th standard, 12th standard, then 3-year graduation, and then comes 2 years post-graduation, and only after that we are going for research. But it is glad to note, it is very good to note that in many different conferences or seminars which are being held recently at different undergraduate colleges, even they are coming up with some poster presentations, or they are coming up with some research work. But actually, whether a real research is possible at undergraduate level, that is the question. Now, with the national education policy coming into existence, we have this objective, or we have this option that on the 4th year, you can go for a research work. It is honors. At 4th year, maybe either descriptive or practical. So at the undergraduate level, what happens? Research is self-directed work under the guidance and supervision of a mentor or an advisor, usually a college teacher. And there is nothing wrong even. There may be some good college teachers who can be, because what happens is in colleges, what we see is, and even few of you may be in colleges, that you are not being getting proper time to go for research activity regularly. Maybe due to differences with the authorities, or the authorities may find it okay, bhai, tumhare atyare jarur. Yeah, I have faced this. I have faced this in 1990s, 94 to 98. That period, I wanted to go for research and I was not allowed. Why? Because it was there. So come tame aagal nikal jao. So this happens to be very strange with it. So at college level, good teacher can guide you. A gradual transition towards independence is encouraged as a student gains confidence and is able to work with minor supervision. Some work which has been already done by some researchers, you can reproduce that. You can do it again at graduate level, so that students can come to know. Now, suppose only few practicals which are there in UG level, say suppose physics or chemistry or zoology or whatever it is. If certain modifications, if you can put up in that and try to explain them, we are doing something new, then that student can be encouraged for research. Students normally participate in an ongoing research project and investigate phenomena of interest to them and their advisor. The advisor may have a project and he may require somebody to help him, so he can ask some meritorious students or some enthusiastic students, come and help me, and that can be possible. So it is possible that at research undergraduate level also you can go for that. Now, which are the areas of science in which we can go for research? Because all of you are from different subjects. I have gone across the chat part and seen that people are there from environment, geology, statistics, mathematics, and all. So we'll go with each and every area wherever it is applicable. Now, the first one is actuarial science. Now, this word is probably not very much common with all of us. Even I was not familiar with this. So I had to ask Google Mahadev, explain me something more about this. So what has happened in the second paragraph, which you can see, or the second bullet point, you can see that I have come with the definition of what is actuarial science. It is a discipline that assesses financial risks in the insurance and finance fields using mathematical and statistical methods. Except for the last 4 or 5 words, you would say that it is not the cup of tea. It is financial risk, insurance, finance fields. Ye apni baat nahi hai. But when you go for the last few words which are there, using mathematical and statistical methods, so science is involved there. So which are the possible carriers in the actuarial science? It will include actuaries, analysts, consulting process, cost estimators, data miners, product development, personal finance, and mathematicians, or you can even have statisticians to be included there. Now, these words are in many ways either totally new to you or less known to you. I've tried to explain in forthcoming slides what would we think about data miners. Generally, mining is right? We just dig out something. And data miners will be mining the data. That is what I presume. Cost estimators will again go with the estimation of whatever product we have formed, and then what profit can we get. So profit minus the preparation cost, that much should be, or the cost price which is there, you want plus 10% result, so high cost is there. So it is generally with the the finance part which is there, but everywhere you have to use that mathematical and statistical method. So science is involved. Now this is a little bit more because I could not make it in two different slides. In biological sciences, of course, we are having life sciences, biological sciences, botany, zoology, microbiology. These are the three main ones where research is being done. And I had a good chance to work under a research master when I was in Lalan College in 1990 to 94. Our principal, Dr. M.I. Patel, of course, I would now say late Dr. M.I. Patel. He was a doctorate in zoology, and he had done research on excretion of the pigeons. કબૂતરની હગારમાંથી જે કંઈ એમને મળ્યું એના ઉપર રિસર્ચ કર્યું. That was probably for the first time I came across what is possible in zoology. So it is not that biology is a sidetracked or sidelined subject and only say chemistry or physics or in say mathematics, they are the main ones. Of course, we are having good research work in these subjects also. Botany, we generally go with the identification of plants, identification of the plant parts, and real identification. So possible carriers which are going to be there in biological sciences, which will be biochemist, you can become a biochemist. You can be quality specialist also. Bioinformatics nowadays is going to be helpful to you. Biology and information technology is combination in bioinformatics. Environmentalists, genetics, physical therapists, lab technicians, virologists, and wildlife biologists. Now, few of these words I have come across more recently because I am busy with admission of my son who has cleared 12th, and so the genetics and environment and bioinformatics, these are the new areas or horizons of science where education is also possible and later on research is also possible. So these are the different areas where you can make your career. For those who are a biology subject, you can use these words. Biological science becomes the study of life from single-celled organisms to complex plants and animals. Biological scientists will study living organisms to better understand life processes. So what they would do is they will try to understand what is the physiology of a particular organism or living organism and why it is like this, why we have amoeba in a different manner, why we have different unicellular plants or multicellular organisms. So why certain big animals or microorganisms are different. All these points they have to understand. They will also study the way organisms interact with their environments. We cannot live in water. The fish cannot live without water. This is the difference which we are seeing everywhere. And why so? What is that? The reason these biological science researchers will be going in that direction. They also study the way organisms interact with the environments. Applied research is problem-oriented, while people perform basic research for the sake of learning. Learning is very important there. Again, with all subjects, the same point is there. Biological science jobs, where are they being available? It is possible that you are knowing almost everything, but suppose 1 or 2 points, if you come to know now, there is nothing wrong. So even when you are, as I told you, there is to be some aim behind doing research, right? So if you have that aim, then it is good. And if you don't have any aim, you can work from these words. So what are these biological science jobs? They will include forensic biologists, cytotechnologists, and even medical technologists. Biochemists and business biologists are two other potential carriers. Forensic biologists work with law enforcement, while business biologists generally work with chemical or pharmaceutical companies. You can just correlate many things now. Take this again. Forensic biologists work with law enforcement. Why? Because forensic science is always going to help the criminal laws to investigate some certain crimes. And so forensic biologists will have to work with law enforcement. Business biologists, they will go with pharmaceutical companies or even chemical companies. That if you are preparing some products, if you are preparing some medicines or drugs, whether they are going to be really helpful or not, for that, obviously a biologist will have to come to help us. Right? Biotechnologists, they will work in a laboratory setting and help develop an environmental products and medical treatments. Technology will be used along with biology, and so the medical treatments or environment products can be thought of very easily. Well, chemistry for me and many of you, there are many areas of chemistry. That includes food chemists, regulatory affairs specialists, science writers, environmental consultants, lab managers, crime scene investigators, and policy makers. Those who are in science may be having a question. We have hardly come across these words with the career in science after research. Our aim is limited, but still you can say that there are wide areas of research in chemistry and huge scope altogether. That is obvious. I would not praise my own subject, but I have seen at many places the BSc students graduate more in chemistry than other subjects, and that is why this is there. Then computer science, because I know computer science is also a part of science, and maybe one or two of you are from computer science. So, well, these are some technological words. I tried to find out proper meanings of them, but I could not, and so I have come up with the same words. They will include analysts. We know very well what is an analyst going to do. Cartographers is related with computer knowledge. Database administrators, programmers, security, and machine learning, software developers, and technical consultants. Nowadays, there is new word coming, that game creation or game designing, right? That is also a new field of computers. So when you come across different games which you may be playing on mobile phones or computers, it is not simple, but it has taken a lot of knowledge of the computer science researchers to come up with that. So computer science becomes the study of computers and computational systems. It is a broad field which includes everything from the algorithms, some type of assumptions that make up software, to how software interacts with hardware, to how well software is developed and designed. See, previously, I would talk about the 90s, when people would go to banks for their passbook entry. They will be writing from a ledger which is there in front of them. They will copy those things in your passbook and get it signed and give it to you. You go to railway ticketing system. There was a card ticket available to you. The card ticket length was, the dimension was about 2 inches by 1 inch or 2.5 inches by 1 inch, wherein it was printed from where you want to go up to where. Then in some space, the clerk would be writing in very small letters the train number, the date of travel, and the seat number which is available. Now, any one of you can be at home and try to find out what is the availability of train sittings or berths, where if you want to travel by night trains. It has become very easy. So it has taken help of many things, software, hardware, everything. Even travel by bus, you are having options. Now, unfortunately, one thing has happened with this, that this research in computer science has probably made us a little bit lazy. Why? You don't go to banks to get your passbook entry done. Of course, generally you don't go to ST bus stand or railway station to get your tickets. It is now hardly 5%. Because previously, when I used to go at the railway stations or bus stations, there were huge lines, and that would tell you, of course, I don't want to go to particular place, I'll come back. But now the computer science, the researchers of computer science, they have come up with much more ease than expected. How well software is developed and how it is designed. Computer scientists are various mathematical organized algorithms, coding procedures, they are being used, and their expert programming skills to study computer processes and develop new software and systems. Then again, we come to information technology that is related with computer science. So I have not put a different, the usual title method which I have been showing you. So IT is also a good research science. It focuses on development, implementation, support, and management of computers and information systems. And the best thing which is possible is you all cannot see me because there is a video problem, of course, but you all can hear me. And I know it is very difficult to hear 4 lectures of 90 minutes each for 8 days still from now. So I'll try to go slow, but I have prepared the material in a way that I thought that I'll go a little slow. And if it is possible that I could not complete in 90 minutes today, I'll take some other day also. But it is really good for the organizers that they have got all 32 lectures booked. So that is really good. So I'll try to be a little faster also in between. And of course, boring is there. So IT focuses on development, implementation, support, and management of computers. It involves working both on hardware and software. The differences are being shown in the brackets. What are hardwares? Control processing units and read access memory or hard disks. And software will be operating systems, web browsers, or mobile applications. These professionals will make sure that computers, networks, and systems work well for all the users also. Now, what careers does computer science offer? Generally, less number of doctorates are coming out in computer science. Less number as compared to other subjects. But it is good to read that, or good to know that the number is increasing. So I really appreciate the research work in the field of computer science also. So computing jobs are among the highest paid today. If you are doing really something good, you'll be paid properly. And computer science professionals report high job satisfaction. Everything, very, very clear things. Most computer scientists hold at least a bachelor's degree in computer science or a related field. But if you are a PhD degree holder, it has to be highly respected and highly paid for. Because after all, it is the highest degree which you would find. So what are the principal areas of study and careers with computer science? You can include artificial intelligence, which is very much common these days, or more heard these days. Then one more word, ChatGPT is a part of that. Computer systems and networks, security, database systems, human-computer interaction, vision and graphics, numerical analysis, programming and languages, software engineering, bioinformatics, and theory of computing. Then we go for data science. They will include cryptanalysis. I've come up with a short explanation which is Sanket Lipi Vishleshak. Some indication is coming to us in some type of language, and if you analyze, it becomes cryptanalysis. Some programmers, data miners, again this word is coming. Information system manager, market analysis, and big data engineers. Now, what is this data science? Because this is a new word or new application or a new academic line coming up. Of course, હવે ઘણી બધી કોલેજોની અંદર આ ડેટા સાયન્સનો અભ્યાસક્રમ ચાલવા માંડ્યો છે. So what is that? It combines maths and statistics, specialized programming, advanced analytics, artificial intelligence, and machine learning with specific subject matter expertise to uncover actionable insights hidden in an organization's data. These insights can be used to guide decision making and strategic planning. Right? So now, for those who are not with data science research area, you can come to know that this is really an interdisciplinary or multidisciplinary aspect. Of course, When I came to know that it is to be for science scholars, this lecture, so I had to deal with all the subjects. I can go with chemistry, but I have to deal with all the subjects. And that is why I have taken up this general topic. Then Earth, atmospheric and planetary sciences, there also their careers are there. They will include astronauts, atmospheric scientists, environmental consultants, geologists, aerospace engineers, geophysicists, and science policy makers. So you are having a field in all these areas. Say atmospheric scientists. In Gujarat, we are having two good ones which are just continuously showing their the forecast on Facebook or somewhere. Ambalal is one of them, and some Paresh Goswami is other, and then there is an Ashok Patel. All these are atmospheric scientists. They have a study of the atmosphere, and they would predict the rainfall to be in one or the other way. So that is also a research in science. Ambalal Patel may not be a very much learned person, but the education which he has gone due to his interest is very much important. Though he may not be having a degree, but he has got a good interest in this field, and so this is there. Then mathematics. I think I have tried to cover all subjects which are there, of the students of all subjects which are there in this coursework. I have tried to cover all the subjects. So possible careers in mathematics, it will include insurance underwriters, biostatisticians, cost estimators, financial analysts, market research analysts, coders, mathematicians, and intelligence analysts. Now, can I know how many of you are from the mathematics side? How many of you are from the mathematics side?
Sir,
Yes.
we are two.
Two people, two students, right?
Yes,
Two
sir.
students are there from mathematical side. Have you come across these words that there is a career like this?
सर उसमें से कुछ नाम हमने सुने हुए हैं और कुछ नए हैं
नाम
हमारे
सुने
पास.
हुए हैं, लेकिन पता नहीं वैसे लोगों को मिले हैं कि नहीं आप,
यस सर.
right? Probably
यस सर.
we even myself, I came to know these words or these areas when I started preparing this presentation. So what I have thought is, we generally believe that a mathematics person would be a teacher only. But yes, we find that there are plenty of scopes in this subject also. So you are getting a new horizon now with this knowledge that these are the areas. Even I could not believe it because I have never came across this. I always found mathematics teachers either at their school, college, or in tuition classes. So, of course, I think this is going to help you a lot. So we generally believe that a mathematics person would be a teacher, but there are good number of scopes. So these are all the areas of research in science which I have covered. If at all any is missed out, well, we can find out for that. So now let us go to the last part, which is careers in physics and astronomy. I think still one or two are there, huh? Please. So possible careers in physics and astronomy. Physics and astronomy goes parallel. They go hand to hand. They include aerospace engineers, astronomers, computational physicists, software developers, design engineers, physicists again, these singular physicists, that was computational physicists, system analysts, researchers, and science writers. These are something new, careers, something new. Physics also, I hope there are a couple of students who may be knowing these things, and if not, you can get it. Statistics, yes, of course, we don't have a statistics subject over here in our university in science, but science, the statistics is always under the science faculty. So statistics, in careers of statistics also you can go, that will include, again, it has come actuaries. Now what is actuaries? I have tried to find out a proper definition over here. A person with expertise in the fields of economics, statistics, and mathematics who helps in risk assessment and estimation of premiums, etc. for insurance business, and all this expertise, the person who carry is known as actuary. Analysts also are a part of statistic future. Data miners, financial advisors, foreign exchange traders, stockbrokers, political scientists, economists, and also statisticians. Of course, when we come across the word stockbrokers, we relate it with share market. And recently, it is share market is such a thing that anybody can be talking about that. Anybody can be sitting with the mobile and trying to know what is available to them. But it always depends on luck. It always depends on luck whether you are going to get that or not. So far as I am concerned, I have tried to be as low as possible on this. When I was in my initial career as a teacher in Lalan College, I came across one good elderly person, respectful person who's still there in this world. He was busy with this stock market. So I told him, let me try. So he said, wherever I will be investing, I'll tell you. So it was that એવું ના બને કે I am telling you to invest here and you are not going to earn. What happened was, in about 4 or 5 scripts where I applied along with him, all scripts of him were approved. I did not get anything. So I have never tried to be so master in that. So foreign exchange traders also, again, maybe you should be knowing actually that $1 is equal to how many, $1 is equal to how many Indian rupees, or one Canadian dollar, how many rupees, or what are the exchange rates, euro, pounds. So these are all statistical experts which may be knowing more, or those who are in that field. Of course, if you are not a statistician and if you are in that field, automatically થોડું statistics ઉપયોગમાં લેવું જ પડશે અને તમને આવડી જશે. So statisticians are also going to be helpful in this. Now, I have come across all the subjects where career is possible. Of course, many of you would have decided your career. Many of you already have a career, but as I told you, as a part of your future progress, you may be requiring this degree. I don't know how much you are going to help the mankind with this, how much you are going to be using this degree to serve the mankind, because whenever I go for a PhD viva, my question is always there: why have you done this and what you are going to do with this? In one of the cases, I came to know that after getting that degree, he had no job and he had to sit with his father's job in a market where he used to sell utensils. વાસણો વેચતામાં બેઠતો હતો. Now he is having a good job with the chemical industry. That is there. So obviously, we have to select properly what kind of field we want. And in every case, there is going to be a psychology involved. Why? Right? Scientific research is important because it helps us understand how things work. Say, suppose an automobile engineer. We take an automobile engineer. He will come up with different ideas. Years back, when in fact, I would say only one good company was known to prepare four-wheelers, and that was Indian company, I would say, Hindustan Motors. And the brand Hindustan Motors had the products like Ambassador. That car used to emit more and more of smoke. Black smoke, વધારે નીકળતો. Fiat was another company. એમાંથી પણ smoke ઘણો નીકળતો. Then came some research. Automobile engineers came up with some research to show that we have prepared something new, some anti-knocking agents have been added, and you will find that this smoke is very less. Nowadays, only in certain old or heavily loaded trucks, you find that black smoke is coming out. બાકી હવે ઓછું દેખાય છે, but does not mean that it is not coming. In addition to this scientific research importance, it further develops various areas of study. Biology, chemistry, psychology, medicine, and all such areas in science are being included. Why psychology? It's not our topic, but still, human psychology says that why I am doing this, only a psychology can help. Moreover, scientific research will help solve pre-existing problems and new ones that might occur in future. All the modifications in food items. Recently, I got a very good comparison. Very good comparison. What is a pizza? What is a pizza? It is a modified bhakri. People come with these words. It's a modified pathway. આળસુ થઈને બેઠો હતો, થોડું જાડું થઈ ગયું, એની ઉપર ટોપિંગ્સ નાખ્યા. So what is that? That is research. And what we have liked it? Too much. Every day we want to go for that menda items, and after few years we start with obesity. We start with problems with cholesterol levels, problems with blood pressure. And so where we go? Doctor will give you medicines, use that. They will tell you go start doing exercise. Cycling is the best one. You had started with cycle when you were in schools. Then financial benefits came to your family. Vitamin M was very much sufficient, so you come up with scooters. Then you came up with earning. You started going with motor cars, good cars, some small cars, and then some big branded cars. You started sitting in corporate offices where you never find sun rays coming to you. So vitamin D deficiency was there, where you find that you are sitting on a table. It's a huge table with revolving chair. You go on the left or right to complete your work. On the right hand corner, you have got your tiffin ready at the noon lunch time. You even don't walk there. You take your revolving chair up to that. What is happening? It is going to create obesity. So science research says that once you have started with cycle, at the end, you again have to go with bicycle to reduce the weight. So moreover, scientific research will also help to solve pre-existing problems and new ones that might occur in future. So what is scientific research? Research was in one way, then what is science has been included there. What is scientific research? Again, when we have thought about research previously, it was some type of information collection. Something old and something new, information collection. So scientific research also includes gathering, organizing, and implementing information in order to understand, explain, or prove a theory or a topic. Why? You have to prove a particular topic. You have to prove that you are doing something new. You have to produce evidences, documents for that. Even though research is vital in both scientific and non-scientific fields, one of the most relevant and comprehensive types of research is scientific research. Anybody can write on this, but because we are in science faculty, I have to stress on this. It is the most relevant and comprehensive. Even commerce faculty, even our arts faculty will require science as a part of research tool, somewhere or the other. Best thing is computer applications. બધાને લાગુ પડે છે. આર્ટ્સ નો હોય તો એ શું? એને ઇંગ્લિશમાં બોલીને કોમ્પ્યુટર જ બોલવું પડે, જેનું કોઈ ગુજરાતી કરી શકતો નથી. Right? So scientific research is like this. So let us go ahead with what is it. Suppose we want to discuss the history of scientific research. What is it? Where it has come from? We have to go back to the beginnings of science and research itself. Science ક્યારે હતું? Research એમાં ક્યારે આવ્યું? So we can see the earliest developments of these two terms can be traced back to ancient Egypt and Mesopotamia, somewhere from 3000 to 1200 before Christ era. કાઢી નાખો 2024 plus 3000. મેથેમેટિક્સ આવડતું હોય તો પણ આપણા માટે આ કલ્પના કરવી અઘરી છે કે આટલે પહેલા શું હશે, whether life was possible or not, because we know only thing is આપણા ફેમિલીમાં forefathers are there up to a particular forefather. Later, prior to that, maybe one or two, but કેટલાને યાદ હોય કે કેટલા જૂના હશે. But still, if we want to go for scientific research, we have to go for the earliest developments of these two terms. How can we go ahead? The modern age of scientific research has seen amazing advances and achievements in the past couple of centuries alone, and it will continue to grow in the near future. Now, we can find that there are lots of changes. Lots of changes being observed, even implemented. Because I think in the previous slide, I had used the word implementation somewhere. Yes, here it is. Implementing information. So whether you are doing that, suppose, take the example. Till few years back, it was I would say 30 years back or so. You putting on a t-shirt was a luxury. Putting on a t-shirt was a luxury. Right? Now, the same t-shirt continues to be a luxury, but in a different kind. Somewhere it's torn out. તાણા પડેલા, ફાડી નાખેલા. કોઈ પેલા જીન્સ પણ એવા પહેરે ને ત્યારે મને એમ થાય કે બિચારો કેટલો ચાલતો હશે કે પર્ટિક્યુલર ની એરિયામાંથી જ એને જીન્સ ફાટી ગયું છે. But that is actually a research to what? Selling things, to earn a lot. Now, how is that possible? For chemistry students, those who have undertaken post-graduation at my department, I may be repeating few words. You are being attracted by the film industry persons. What a good dress he or she is having. ये लोगों ने उन सबको वो ड्रेसिंग करने के पैसे मिलते हैं, जबकि हमको पैसे देने पड़ते हैं, तब भी वो ले सकते हैं. फिर भी हम तो जैसे अच्छे लगने वाले हैं उतने ही लगेंगे. Not so sharp or charming as XYZ actor or actress. So modern age of scientific research will be having different advances and achievements in the past couple of centuries. So you can come across that also. So next, what is the scientific research going to do? It's going to use a wide variety of scientific models, theories, and data collections to find explanations for why certain phenomena occur in the real world. Now see, we are in Kutch because we are going to get a degree of Ph.D. from Kutch University. So we should assume that you are in Kutch or you are Kutch University students. And Kutch is more prone to earthquakes, right? The 2001 earthquake was massive by all means. What kind of noise it created when it started shivering? I had heard that when I was in Jamnagar on the Republic Day parade because the earthquake took place on 26 January itself. And after a few months of time, or rather probably round about that only, I visited the District Science Center of Jamnagar at the Drol village, and I found that the programmer or the coordinator of that particular science center, Sanjay Pandya, who happens to be our student, they created a model to make you realize what would be an earthquake. You feel karave. Same thing now is here at the Multidisciplinary in the earthquake museum. If you go into that show after getting a ticket for that, it is being I have not visited, but I have come across to know that if you are there, you will be given a chance to realize or feel that earthquake has come. So that is scientific models, theory of earthquake. All the geology persons may be very much aware of these things, and the other science faculty persons may be having some knowledge of how earthquake takes place. I remember in 2001, it was said that આવડો મોટો earthquake આવી ગયો. હવે એટલીસ્ટ 30-35 વર્ષ સુધી આવડો મોટો earthquake નહીં આવે. What is worrying me or anybody else is now hardly 7 to 10 years remain before that such massive one comes. શું થશે? કે હમણાં થોડા વખત પહેલા પણ એક IIT કાનપુર કે some other area students have come across with a study that the fault areas are becoming active and anything can happen in near future. I hope that near future should be equal to that previous prediction of 30 to 35 years. But theories, assumptions, data collections, they will find explanations for why certain phenomena occur in the real world. I have tried to connect geology over here. We can also collected physics, some part of physics with the model preparation, all these things. You, in that way, take your subject, put up the models. So in chemistry, you can come up with models of stereochemistry or group theory or something like that. Or even with organic chemistry, explaining the bond formation by some models. It's possible. Whether through experiments, case studies, or a focus group, scientific research can be executed in many different ways. And the end goal of a scientific research is to broaden human knowledge. At the end, yes. Now you can see that in chemistry, more and more research is being done on new drugs, almost in all universities. And one common thing they have come up with, we are trying for anti-cancer drugs. I appreciate it because cancer has become such a vast spreading disease that we will require many medicines for this. Of course, there is no guarantee of how much a person will survive or not. But when you are going for anti-cancer activity for your compound, and if you find that something good result is available to you, my request to all such researchers would be try to elaborate more on that, approach certain chemical companies or drug manufacturing companies, tell them I have come up with this, try to get some modifications or alterations or some guidance, and come into the market and show that yes, my product is going to help cure cancer. Right? Thanks to scientific research, mere observations and theories can be transformed into practical learning and established practice. See, natural products are such a source of research that anything is possible. You can go through many things of that. But again, nowadays, that too has become too common. I would rather say for my subjects, many things have become very common. And that is why really good, interesting topics are not available. Still, we are trying to find out something new because, after all, you all have come into research and we are going to guide. Now, when we have thought of an importance, what is scientific research? Let us come to what are the types of scientific research. Now, see, again, going back to different research-related lectures during your previous coursework, that what are the types of research? Qualitative, quantitative, exploratory, analytical, descriptive, etc. All these belonging to the research methodology book of C.R. Kothari. Right? So there are many different types of scientific research. You can start from quantitative research to qualitative research or to mixed one or even explanatory. And you can classify this in many ways. So the classification will depend on the research method, data collection techniques, and of course, the research problem. Where actually you are standing, what actually you want to do. See, recently the elections have been completed. You have got a different kind, a result which was rather less expected for few, expected for others also. But there you can find that statistics was being used to research for the exit poll. There, quantity was being used, the population was being used because it was based on quantity. Of course, there were good comments coming up in Facebook that we have never seen such persons coming to us for a survey, right? It is obvious. So now, since it can be classified in numerous ways, the classification will mainly depend on the research method, the data collection techniques, and of course, the research problem. How do you collect the data? It can be manual directly, it has to be manual. Or it can be by some help of secondary work. See, I can talk about one thing. It is always going to be manual. Somebody is sitting idle. He or she does not have any work, but he is willing to do work. You can call him at a particular place in your city where you find maximum traffic, road traffic, vehicle traffic. Just you look at the different vehicles coming in front of you. Direct vehicle, rather each vehicle will be having red lights at the back. Why? It is to show you that I am going ahead. Please be careful. Don't come on me. But it sometimes happens that one of those bulbs have gone out of order. So both lights may not be visible. So you can tell your friend, come on, sit over here. જેટલા vehicles અહીંથી પસાર થાય છે એની પાછળની ચાલો three wheeler vehicle હોય, 4-wheeler હોય, 6-wheeler હોય, whatever it is, એમાં તમે જુઓ કેટલાની લાઇટ ચાલે છે. What you are doing that? You are going with quantitative research. Then you survey કે જે vehicles ની lights સારી હતી, બધા હતા, એમાં કયા કંપનીના vehicles હતા. It will become a quality research. You can propagate, you can research, you can tell more and more students and friends that yes, you go for this particular vehicle product. Any lights ક્યારે બંધ હોતી નથી. અરે ભાઈ જરૂરી નથી કે એ કંપનીને કારણે હું છે. The person who is taking care of the vehicle also may be having that habit કે મારી vehicle ની light બંધ થવી જ ન જોઈએ. Of course, હું red light અને black light ની વાત કરું છું. But nowadays it is that the white light and the yellow light in the two-wheelers which are coming for 24 hours, એમાં પણ ઘણાને ડીમ લાઇટ ને ફૂલ લાઇટ નો કોન્સેપ્ટ ખબર જ નથી, ચાલ્યા જ આવે. મેં એક બે જણાને પૂછ્યું બહેનોને, આ કેમ ચાલુ છે, બંધ કરો, તો કે મને એવું ખબર જ નથી. So that is not an education. So quantitative and the qualitative, these are the main differences or main different types of scientific research we can bring. The main distinction of scientific research is between these two, what we can see. The quantitative research being the quantity. It research, as the name implies, includes studies based on numbers. Quantitative methods can either imply counting or measuring some type of data. Since this type of scientific research is numeric, its aim will be to evaluate the when, where, and what of the research topic. Take any common example. Vehicle no example પાછો લ્યો. Emission of carbon monoxide from gases. During a smooth run, during a steep coming high, slope ઉપર જાય ત્યારે શું, slope થી નીચે આવે ત્યારે શું. In all these 3 points or in all these 3 ways, you will find that the emission of carbon monoxide will vary. And then the environmentalist will come across, આટલું તો environment બહુ આના કારણે બગડે છે, so there should be something. So there will be bioengineers in that case. They will help out to do research and knockers and anti-knockers કે કંઈ પણ નાખીને તમે ધુમાડો ઓછો થાય એવું માનવામાં આવે છે. Right? So it's mainly expressed in numbers, statistics, and graphs. The methods which are there for quantitative data collection becomes surveys, experiments, and observations. The one which I gave you an example is an observation. It basically measures numerical data in order to discover patterns. What are the patterns going to be? That becomes numerical data. Now I can feel after this about 1 hour lecture that it is not going to be so very easy for all to be continuously active on this. And I'm rather gone a little more than halfway, and I've got only 30 minutes left with me. So I'll try to cover up as much as possible. Otherwise, I'll tell Gaurav bhai, if at all there is a break somewhere, somebody could not come up. One day prior to that, if at all something remains, we can go. Right. So now let us move to quantitative research is clear with us. Let us move to qualitative research. This will focus on the quality of the data. See, I am just relating once again the vehicular part, because I was always interested in these things. Years back, when I told you we were having ambassador cars and Fiat cars, and then came Suzuki, that is Maruti Suzuki, and they came up with the Fronti, the smallest model in those days, 40 years back, 40, 50 years back, smallest model. So it was known as Maruti. And people found it so convenient, so easy, that they can easily ride that vehicle at a speed of more than 100 kilometers per hour, where not a single driver was aware of what could happen at 100 kilometers speed. But the joy was solid. And then due to that, more and more accidents took place and people died. So what happened with that quality? I would come up with a slogan which was there previously, very good years back. Ambassador starts with A or A, Aram Mate. It was a most convenient vehicle, sturdy vehicle. And people enjoyed traveling in that. Even I have enjoyed traveling as well as driving, both. So you can feel that કેટલી જૂની વાત છે. Of course, I got my license probably in 1992 or something like that, 93 or 92. Then ambassador was for Aram. Fiat starts with F and F starts with Farwa. Fiat Farwa Mate. It was also a very convenient car, so you can go very easily to for long distance driving. But when these accidents took place for Maruti vehicles, so Maruti was starting with M. M stands for Marwa Mate. These were the 3 slogans used. So what happened? What this relates is quality. Of course, there have been huge modifications now, and now with more and more branded vehicles coming up, the percentage of accidents or fatal accidents have gone down drastically, because people have started realizing that ઝડપની મજા મોતની સજા સાચી વાત છે, right? So what is there, quality research will focus on the quality of the data rather than the quantity. If I want to start a college, I want more and more number of students, 70, 100, 150, that is quantity. But I want to prepare only a few, 20, 30, but give them quality education. That becomes a qualitative part. So rather than the quantity, this is a type of exploratory and descriptive research, which is why qualitative methods will include case studies, interviews, focus groups, literature reviews, and similar. See, for a particular subject, if the research topics are very closely related to each other, I think it is not going to give you good satisfaction. You should, when is this possible? If you have got more and more number of students working on the same area, then it is going to be difficult. So scientifically, that research is going to be a question mark. As opposed to quantitative research, because quantity ni same qualitative આવે છે. As opposed to quantitative research, the qualitative research will aim to investigate the why and the how of the decision-making process. More and more number of Maruti vehicles were being damaged by accidents. That was an observation. More and more number, quantity. Then came the quality aspect. Why that happened? How that happened? So then came the modifications in engineering side. It is achieved through organizing, interpreting, and summarizing data, or you can even say qualitative research is used when you want to understand textual data, what is there in this theory, and then you can go for that. As opposed to quantitative research, which aims to test a hypothesis with the help of numerical data. The aim of this form of research is to get a better understanding of the given topic or the potential issue it may generate. This will ultimately lead to a solution, because quality will always lead to solution, which may or may not be based on empirical data. Chemistry research scholars may just correlate this qualitative part with the qualitative analysis and the quantitative analysis which you are doing in practicals at graduate level more as compared to postgraduate level. You can find that gravimetric analysis were based on the quantitative methods, whereas the inorganic or organic identification of salts or functional group, it was based on quality. Then there was a word mixed research. It is a combination of quantitative as well as qualitative methods. It is valuable. Why? Because it will enhance the strengths and diminish the weakness of both quantitative and qualitative research. It will enhance the strength. You can use the combination and it can give that. It will diminish the weakness. You can be more powerful thereafter. Applied and basic research also comes out to be a part of scientific research, and there is a distinction between them also. What is that? Applied research. It is conducted in order to solve particular issues by using already familiar and accepted knowledge, theories and principles. This we have already discussed in previous slides. This type of scientific research entails a variety of experiments and case studies, and it also investigates the relationship between variables and principles. It also investigates the relationship between variables. It's solution driven, since its main goal is to provide a practical solution to a problem that has already been defined. And basic research and classification research can also be thought of in this same manner, right? Basic will be fundamental, and classification research will seek to organize units of data into categories as well as to demonstrate the difference between the relationships. Now, if you are going for research in the field of science, what can be the different steps? As I asked you a question, or rather I put a type of question in front of you in the beginning of the presentation, that there would be some aim behind doing this research. Why do you want to go for PhD? ભાઈબંધ જાય છે, બેનપણી જાય છે, માટે મારે જવું છે, બસ કાંઈ કરતો નથી, MSc કે MA થઈ ગયો, MCom થઈ ગયો, કંઈ છે નહીં, ચાલો આ કરી નાખીએ. That is your aim which is being thought of. Now here, when you have already selected to go for scientific research, what are the steps involved? First one is ask a question, and question does not mean what is your name. સાવ સીધું સાદું નહીં. There is nothing research in that. હા, name no meaning માંગો તો ખબર પડે. You ask for a meaning of your name. Why you are named by this, identified or known by this name? What is the meaning of your name? Then it is something which is questionable. No matter the topic, every type of scientific research has to start with a question. Wherever you go, question is going to be there. Why? How? What? હિન્દી ફિલ્મના ગીતોમાં આવું બધું બહુ આવે છે. ક્યાં મળશું? તો કે ત્યાં જ જ્યાં આપણે પહેલી વાર મળ્યા હતા. Whatever it is. Why, how, and what. Therefore, the first step is to identify the research problem, apart from which field of science you are publishing, maybe arts, humanities, natural science, psychology, whatever it is. Research problem has to be identified, and this is all you have gone through. Of course, all of you have come up with your research title also. Proposal has been put up. Right? બધાએ મૂકી દીધી છે. છે જ આપણી પાસે. So what we started with is question. At the very beginning of your research, you are allowed to make predictions regarding the topic. Now the next question comes, why have you selected this topic? I have to see, as my principal, Dr. M.I. Patel, came up with that topic of study on excretions from pigeon. Why? Why did not he try for crows? I asked him. So કે અમે જે કોલેજમાં ભણાવતા ને એના દરેક લગભગ દિવાલની જે મતલબ બારી હોય કે વોશરૂમની બારી હોય કે ક્યાંય પણ maximum these birds which are available were pigeons. So it was easy for us to do our research on that. So that is a convenience, right? So at the very beginning of your research, you are allowed to make predictions regarding the topic. The prediction can be based on existing theories and knowledge or your own theories. વર્ષો પહેલા એવું બનતું હતું કે બહુ ઇઝીલી PhD થવા જાત, બહુ ઇઝીલી. મરચાની જાત ઉપર PhD. સો મરચા જનરલી બોટનિકલ એસ્પેક્ટ અને થોડુંક મેડિસિનલ એસ્પેક્ટ આવી જાય તો મરચાની ક્વોલિટી, મરચાના ટાઈપ્સ ઉપર PhD. Then came with some different things. Even today you can find that a particular say tomatoes. One are deshi and specifically grown tomatoes. They are different. And so they have a different taste. We have never seen very small watermelons. Now you can get huge sized but very small watermelons. પહેલા તો બહુ મોટા મળતા, 5 કિલો ને 6 કિલો ના મળતા. હવે તો 2-3 કિલોમાં તો આવી રહે છે. પડી ન જવાય ને, થાકી જાય, હાથ દુખી જાય. કોઈ બીજું એમ કે જબલા થેલીમાં ન આવે એટલે 3 કિલોથી વધારાના સાઈઝના ન ચાલે. So this is also a research, right? So the prediction can be based on existing theories and knowledge of your own theories. Then second one, do background research. Why, where, what we have done now, background. Suppose you are working on some marine plants. You will find those marine plants only near the sea water, not in the desert area. So marine na kehvay. Obvious. So after you decide what type of information your research study will be based on, the next step is to do background research. Why this plant is being observed more in this area and not somewhere else? See, you can take the case of mangoes. Good Kesar mangoes are available in the Gir area as well as in Kutch and now also in Valsad. Whereas Valsad was more known for the Hafuz mangoes. But they have tried to change it. And once you change, the taste will differ. What is the taste of Kesar mangoes in Gir? It is different in Kutch. It is different in Valsad. So it happens. After you decide what type of information your research study will be based, you go for the background research. This is where you will make an overview of the previously published literature. પહેલા જોઈ લેશું બધું, where it is, કેટલું કામ થયેલું છે on the topic that you are interested in. See, when I was doing research, what topic which I selected, I wanted to get more information of that. Those days, there was nothing like this Google, nothing like this InflipNet directly, nothing like this easy search. There was an agency in New Delhi. We had to write them. I want more and almost all information regarding the work based on this topic. Kindly let me know the process. So from that, they will search out and come up with a letter that for your question, there are about 40 or 50 surveys being done, and this much work has been done. If you want the information of all this, you will have to send money by demand draft, not NEFT transfer or anything. That for those many pages, this will be the money required. Once you send that money, we will send you the entire bibliography. Now, very easy. Literature review, you can do it very easily. At this point, you are supposed to gather enough resources and literature to use as references. The more evidence you have, the better chances of providing your theory. Now, suppose you are going for a particular question on Google. What happens is, on a particular one particular window, you may get, say, suppose 10 or 12 such websites for which your question may be having answers. Once you scroll down, you'll find on a horizontal line that page number 1, 2, 3, 4, etc., etc. That means your topic is not related to only one page. You have to go to the next page. Information go to the third page. So it now what our knowledge has become, or what our habit has become, is we don't go to all such things. પેલા 2 કે 3 પેજમાં જે મળ્યું લઈ લ્યો, પણ ભાઈ પાછળના પેજમાં પણ થયેલું કામ હતું અને તમે એ જોયા વગર એ રિસર્ચ બતાવી દો તો કેમ ચાલશે? So more evidence you have, the better chances of proving your theory has to be there. After what asking a question, going for the background research, we are now constructing a hypothesis and collecting data. I think this has been already discussed previously, so I don't want to go into deep depth of this. Conducting your own quantitative research is coming up with hypothesis. Hypothesis is one kind of assumption that the entire research project is all going to be about. When it comes to qualitative research, the next step would be to collect the data. This can be done through interviews, focus groups, etc. The next is test your theory. After you come across your field of research, close to the field of research, try once whether we can do good things in this or not. So a hypothesis is being done, data has been collected. Now you have to test your theory. In chemistry, when you are going for new compounds which are going to be medicinally useful, you go for a test. You can select the research method that will help you achieve your goal most efficiently. Depending on whether you have chosen quantitative research or qualitative research or even a mixed method, the next step is to do a study. This you can do. This can take the form of an interview, a case study, some questionnaire also, and a focus group. And finally, we can say that you can go for evaluation of the result and even make a conclusion. What actually you come up with. Which are the different scientific methods of research? I think I may require some more time, but I'll try to finish up fast. Don't worry. So there is a systematic approach to scientific research. You acquire it. You have to aim to acquire new information that will add to the existing knowledge in the research field. Till Corona came, it was simply blackboard or whiteboard, chalk and pen, which was used to teach you people. Corona came, students were not allowed to come in the class. So obviously, this particular mode of explanation started, which is still continuing. I know, because I know if you want to conduct coursework over here physically, it is going to be a very tedious job for many. Even all stakeholders, even the resource persons may find it difficult to come over here, or you students may find it difficult to be here. But any maja judi che. Amtham tu nathi kehvaતું old is gold. There is a big science behind that. Old is gold. Right? So the consensus of scientific research is that researchers should plan their investigation before executing it. You have to come across good things before you start doing your work. Atla upar kaam thayun che, nathi thayun, then you can go ahead. This is important as it can help identify if research is observable, empirical, objective, valid, and reliable. So these are the key features of scientific research. But how can we tell if research is scientific? Similar to how products are quality assessed before they reach commuters, research is assessed using quality criteria. Quality criteria becomes the standards of qualitative and quantitative research. For example, you can think about validity, some reliability. આજકાલ guarantee ની વાત વધારે આવે, guarantee, warranty, etc. Empiricalness, objectivity, these are essential in quantitative research. Whereas transferability, credibility, confirmability, these are of the qualitative research. What can be the aims of doing this research? It will identify, or it will aim to identify and build scientific knowledge that discovers and explains laws or principles of natural or social phenomena. There tend to be multiple explanations proposed by various researchers to explain a phenomenon. एक वस्तु ने why, how, what, many people can explain in different ways. The aim of scientific research is to either provide supporting evidence or disprove them. It has to be scientific. Research has to be scientific. Why? Because it leads to the progression of our understanding of a phenomenon. And if we go on this, if we do something, some good findings, you can outline motivations, drives concerning individuals, thoughts and behaviors. They can also discover how illness occur and progress, or how to treat them. આગળ ને આગળ ઘણું વિચારવાનું છે. સપોઝ ઇન્ડસ્ટ્રીમાં જઈને જો હેલ્પ કરવાનું હોય કેમિસ્ટ્રી વાળાને, તો આમાં ઘણું બધું તમે કરી શકો એમ છો. Why research has to be scientific? Because since research is used, for example, to test the effectiveness of a treatment, it is crucial to ensure that it is based on scientific and empirical data. કોની ઉપર ટ્રાય કરશો? Suppose I come up with a drug which says that it is an anti-inflammatory drug. I cannot try it directly on a human being. કારણ વગરના આપણે એનિમલનું ભોગ બનાવીએ છીએ. એનિમલમાં પહેલા ઇન્ડ્યુસ કરીએ છીએ some with some injection or something, એનામાં swelling or inflammation આવે. પછી આપણી દવા એને આપીએ છીએ અને ઇન્ફ્લેમેશન કેટલું ઘટે છે દેખાડીએ છીએ. એનિમલ્સમાં આ વસ્તુ થાય છે. I don't know whether the same can be done with human beings, but you are given permission to try human beings also. Why? How did the corona vaccines be helpful? Because they were tried on animals as well as they were tried on human beings. જેને સિવિયર કોરોના થયો હોય તે ખબર જ હોય કે આ જાશે, એને ટ્રાય કરી લે. પડે છે? યસ, પડ્યો છે. Then go ahead. It was a good achievement on the part of our scientists that we could provide good vaccination. So people get the correct treatment, they can improve their condition. Again, there is one more point. Why the research has to be scientific? Because it ensures the findings collected are reliable and valid. Reliability and validity are essential because they guarantee that the results apply to the target population and the investigation measures what it intends. એમનેમ દવા નહીં બનાવી નાખવાની, એમનેમ બજારમાં નહીં મૂકી દેવાની, પછી કાંઈ ન થાય, આપણે ફસાઈ જઈએ. What are the classes and types of scientific research? They are based on different categorizing system. For example, whether the study uses primary or secondary data, what type of causality relationship the data provides, it is also there. Three main ways of categorizing the research are to identify the purpose. One is exploratory research. I'm not going to more detail of this. Descriptive research will examine the questions regarding the what's and whens and where of the phenomena. And there is also an analytical research part which will provide explanatory findings of phenomena. It finds and explains causal relationships between the variables. Then some examples of scientific research. Research can be identified as a primary or secondary research. It can be determined by whether the data used for the analysis is collected themselves, or if they use previously published findings. So you can even go for laboratory experiments, some field research, some natural experiments. All are having some different ways and means of carrying out these things. Although these examples are all regarded as scientific research, what you require is laboratory experiments are to be considered the most scientific and natural experiments, at least, because you cannot say નવા બની ચાલો આપી દો. નહીં, ઘણી વખત એવું બને છે કે લેસ એજ્યુકેટેડ ફેમિલીઝ ને સોસાયટીની અંદર એમ કહી દે મેં આવી દવા બનાવી, એમ ચાલ મને આપ. પણ એને ટેસ્ટ કર્યા વગર you cannot go ahead. As in lab experiments, the researchers have the most control and the natural experiments have the least controlled thing. Now, secondary research is the opposite of primary. It involves using previously published research or data. You have come across this. Examples of secondary and scientific will be meta-analysis or systematic review, or a review when the researcher critiques another researcher's published work. And the scientific research will have some key takeaways. આવું જો કરશો તમે ક્યાં જશો? The scientific method of research will always suggest that the research should check mark the different criteria like empirical, objective, reliable, and valid. The aims of scientific research are to build scientific knowledge that discovers and explains laws or principles of natural or social phenomena. The primary scientific research examples will include field and natural experiments, and that will lead to secondary and scientific research, where you can find examples like meta-analysis, etc. Laboratory experiments are also considered the most scientific type of scientific research. And now I am coming to the best slide of this. Shall I show you the best slide of this presentation? Okay. Because I think that you are bored, the best slide is going to give you something new to cheer out. If you are honest enough, those who have liked this slide and not the others can raise your hands. આ સ્લાઇડ સૌથી વધારે ગમી છે, બીજી નથી ગમી તો તમે હાથ ઊંચો કરી શકો છો. But I know you will not, because સાહેબને ખરાબ ન લાગવું જોઈએ. Anyway, I have tried to finish up well in time before the next lecture starts. I know questions are not going to be so easy because you have to go across these things. From the coordination team, can anybody tell me whether I'm required to put up some questions in as a part of assignment or something? Am I required?
No, sir.
Huh?
Sir, it will be provided by the research and development cell itself to the students.
Okay, fine.
For the phase 3, we will be providing the set of seminar and the set of assignments from here itself.
Okay. Otherwise,
Yes.
I can give you. Well, so I think the next
No,
speaker
we
is
will-
already ready. And thank you all for patient hearing, because આનાથી વધારે તમે શું કરી શકો સાંભળ્યા વગર? ડિગ્રી જોઈએ છીએ તો ગમે તે કરીએ. But no, I request all of you to take this project of yours of doing research very seriously, for the good of the human mankind or human beings, for the good of the society, so that you can help everyone, not just with your degree, not just with your own progress, but with the help to the society that is more required. So all the best to all of you, and thank you for a patient hearing, and thank you the organizers. Thank you.
Thank you so much, Baxi sir, for the insightful lecture. And I hope all the students really liked it and they have learned from it as well. Thank you so much, sir. Baxi sir, with your permission, we would like to start the next lecture. Our next speaker is Dr. Bhawanisingh Desai. He is from PDPU University, and he is the Dean of Research and Development there. So I welcome Bhavani sir on behalf of all the students of the science faculty. Over to you, sir.
Thank you. Is my voice audible?
Yes, sir, it is audible.
Yeah. Okay. So we'll start with, today I would like to present on multidisciplinary aspect, how multidisciplinary science they work in a petroleum industry. Okay. So if you can allow me to share this. Just give me 1 minute. Yeah. Is this visible to you, the full screen?
Sir, it is not visible as of now.
Okay, just give me another. Yeah, is it now visible?
Yes, sir, it is visible now.
Okay, okay. So in what language would you like to hear? English or Hindi? My Gujarati is a little bit weak, but not that way, especially in technical terms.
Sir, both languages will be better. We have students from science faculty, so English is very efficient, but Hindi
Okay.
and usage of Gujarati is also appreciated.
Okay, wonderful. So wherever possible, I can switch. So I'll basically deliver in English, and wherever you have questions, you can stop me and you can ask me. Okay, I want it to be more interactive.
Sure, sir, sure.
Yeah. So so before, see, this is today's title, that is application of multidisciplinary science in petroleum energy. Let us look at what is the energy, what we understand by energy. Okay. If you look at past 75 years of data and future 25 years of data, that what is the primary energy consumption for the world? This is a very important graph which highlights many things. See, since 1950 to 1980, the main primary energy consumption was coal, oil and biofuel together, and natural gas. 1970 onwards, we added hydro, and 1980 onwards, we added nuclear. Okay. When we come to 1920s, we are still with oil, coal, hydro, nuclear, and maybe we have added few wind and solar. In few will come. So if you look at the consumption scenario of what is primary energy, you still have the traditional energy domains that will remain, and that is going to be there. So my today's lecture would be on this traditional domain, that how oil, biofuels, or oil and gas, natural gas, they are studied, what kind of multidisciplinary approach it takes to find this and use this hydrocarbons. Okay. Now, first and foremost thing, oil and gas is divided, this entire business is divided into three components. The first component is known as upstream. The second component is known as midstream. And the third component is known as downstream. So many of you have heard about this term called as Reliance Jamnagar Refinery. Have you heard about this? If
Yes,
you have
sir.
heard, then you are looking at this downstream sector. If you have heard about ONGC, this is typically an upstream sector. And midstream is where you have this pipeline coming to your home. So we have these three separate segments, and each of this segment has its own way of looking, its own way of working. Today, I will mainly focus on upstream sector. So upstream has a lot of integration of all subjects. It specifically deals with finding of crude oil, bringing that crude oil up. Okay. And this has a lot of challenges. So today we will discuss mainly on this. And this is where the geology comes into various importance here. So it is here where geology is implemented in its full potential. So this is a very conventional way in which we look at oil and gas. We have folded rock layers through which we find oil and gas. And just imagine that from the top surface, we are exploring nearly 2 or 3 kilometers below the surface, and taking out oil and gas. So this is a challenge. Coal, everything comes on a very shallow area. So there are a lot of multidisciplinary science and engineering that goes in recovering this oil and gas. And it includes everything. But the base is geoscience, because if you don't understand the rock, you don't know its porosity, permeability, what type of rock it is, at what depth it is, you won't be able to find it. So now we come to present day. Now this triangle is known as resource triangle. And what you see is on the top where you have oil and gas. This oil and gas is the conventional oil and gas, which is easily found and which is right now it is there. But 2/3 of this triangle, it contains what is known as unconventional reservoir, which are very large volume, but it requires a lot of technology improvement and its product price may also increase. So as compared to oil, you require a very higher technology to recover tight oil, heavy oil, and bituminous sand. And believe me, these are in more abundance than what we know as oil. In more abundance is oil shale. Similarly, on the gas side, you have coal bed methane. That is methane which is entrapped in all coal bed. You have gas shale and you have gas hydrate. For example, if you look at east coast of India, starting from Odisha to Tamil Nadu coast, the entire that area patch has a huge resource of gas hydrate. Okay, but the problem is how to recover or how to take out that or utilize that resource. It requires improved and very advanced technology, and it includes lot of price variation also. Now we come to another challenge where there is a multidisciplinary. You see, in lot of renewable energy, we simply think that, oh, we can simply replace oil with solar, wind, nuclear. But this is not how it works, because the raw material that you require to build the solar panel or wind turbine are something which is called as rare earth elements. And these rare earth elements are difficult and more expensive to recover, more economically not feasible, and they are more of CO2 giving resources exploration. So in short, changing one energy form to other energy form is also not a solution, and it requires a lot of technological advancement. If you see this graph in very simplistic manner, in 1700 or 1800 century, you only had windmill, and that required iron, calcium, and carbon. That was only elements that you require. But as you come to steam engine in 1800, you required a lot of lead, copper, magnesium, all those things. And when you started getting our petroleum car, that is where all these minerals they started growing. And especially in this now 2000, when you're producing solar panel, you want lot of rare earth elements, okay, to be embedded, because that they became very efficient. Lithium is used for lithium ion battery, okay, gold, cadmium, gallium, all these elements are very important. So to give you an introduction, energy is diverse. We would be still using the traditional energy methods. There won't be much major change, but we would be adding because our demands are increased. And with addition of this, more technological improvement is required. So that is where I come to what is geology now. Now, geology is a basic answer to everything. Whatever technological advances you're looking, the geology is the answer, because all this resource are related to geology. Whether you take oil and gas, you take the renewable energy sector where you require rare earth element, that is also geology is there. So geology would be a very key answer to everything. And I will quickly make you understand what aspect of geology are required in petroleum industry. So first and foremost, you have this all aspect, air, water, land, and life, all coming together as that we are forming the earth. And these all interactions are very important to resource generation. Any resource that we are talking, whether it is an mineral resource or an oil resource or a water as a resource or biofuel, this interaction of this 5 element, that is important. So I think most of you know that the earth crust is there, and earth is divided into 3 layers. You have crust on the top where it is a solid. You have the mantle where a lot of convection happens. Convection means there is a flow of molten material. So hotter material, they come up, and colder material, they go down. So this creates lot of convection. And these convections, they affect the crust. And when they affect the crust, your basins are formed, that is shallower body, and mountains are formed, that is the thickens. And this variation, they help in building the mineral resources. And the second thing is that below mantle you have core, again, which is divided into 2 different forms, that is outer and inner. And when you see, if you drill deep into the earth, the temperature goes on increasing. And this is because the heat that is coming from the core and mantle, it is precipitating, and the total interior heat flow is somewhat like this. So there is a connection of exchange of heat, which together with geological processes, it affects the how the resources are distributed. Now, just to tell you what are the domains or disciplines involved in this understanding. So understanding this simple heat flow, you require a very solid understanding of geophysics, 1. You require a very solid understanding of geology. You require understanding of physics. And 4th, you require very good understanding of chemistry. So these 4 disciplines are involved in the simple diagram that is showcased here: physics, chemistry, geophysics, geology. And to sum up everything, maths is also required. So now we will see what geology, how do they look into this. So geology have a very simple understanding of rock cycle. That is, you have a sedimentary rock which converts into metamorphic. Then because of the convection, it goes into the mantle, it gets molten, it gets magma, it comes out as an igneous rock, and then this igneous rock or metamorphic rock, they basically weather. And this weather, it produces sediment which deposits as a sedimentary rock. Now, in this entire cycle, at every phase, that is sedimentary rock or metamorphic rock or igneous rock, each of this will have a unique pressure and temperature regime, which in back it gives the way any important mineral is getting deposited. Galena or agate or halite, okay, or anything, or any metallic mineral, okay, gallium or chromium, all these are formed at one of these phases. So we must understand how this rock cycle is important, locating and extracting the magnitude of natural resources, that is also involved with this, and evaluating the environmental impact. So the second part is, the most of this geological time period was divided. Say we as a geologist, we look at a time slice from today around 541 million years before the life evolved. And the way life evolved, it has again impacted the resource which was distributed. Okay, so if you look at the globe which is there is a very high diversity of animals or organisms living around equator. And this diversity goes on reducing as you go towards the pole. Now, what has happened here? Because of this diversity and distribution, it has also impacted the way resources are utilized. Okay. And most of this high diversity area zone are also the zones for some of the secondary resources like carbonate. Okay, they are very prominent here. Coral reefs. Okay, it has a very high potential of CO2 absorption or CO2 release. So both way it happens. So to tell you that since our 500 million years, Earth started at 4.5 billion years, but from there to 541 million years, there was a lot of time where there was no life. Okay, and most of this petroleum people, what they derive oil and gas is from these dead animals and plants which were surviving during this entire geological time scale. So here your input of biology as a discipline, paleontology as a discipline is also very important. Are we clear with this? Nowadays, you are also listening to what is known as CO2. बहुत CO2 reduction करना है, ये करना है. But is it real or it is something made up? So as a geologist, we understand that CO2, which is there in atmosphere, it keeps on a cyclic mode. Sometimes it is low, sometimes it is large. There were certain times when the CO2 emission, natural CO2 emission, was more than what is today. Okay? But it has affected the earth in a different way. What has impacted is that there is a anthropogenic, that is human induced rise in CO2, which has imbalanced the natural absorbing capacity of CO2. So there was a one time when there was no oxygen on earth. Oxygen started coming around 2.2 billion years before. What was there was very common was CO2. And then there was a lot of temperature fluctuation. Things were very different as compared to what we are looking at. They were more serious. So all this understanding we come to know through geology. So on the geological side, we come to know that there are certain minerals which are really important to us, as if you want to look at the energy, if you want to study or use energy. And these mineral resources are distributed in a very different way across the globe. And it has been impacted by the time, the CO2 emission on the geological record, and the way the animals and humans were utilizing the resources, especially the animals. Human came very late. Okay, So if you look at this, look at which are some of the very important minerals and how they are located. Okay, so this is how it is. So out of this, if you look at the red triangles, they're very important. Red triangles are small, but that is where gold is there. Chromium, copper, yellow dot, okay, titanium, green dot, okay, gypsum, or these are all some of the very important minerals which are now used in our renewable energy. This is how gold look like. Okay, this is a nodule. On your right hand side, this whitish mineral is nothing but diamond, and this red color is nothing but iron. Okay, we are very fascinated with these two things, but remember, diamond is formed in a igneous plug, what we call it as kimberlite. Gold is formed in a specific tectonic setting. So even to mine this, we must have a multidisciplinary approach of geology, structure, mechanics, okay, because you're going to mine it. The geomechanical property of rock, how the stress and strain are oriented, and lot of chemistry is also required here. You can identify this when you know the chemistry of this. Otherwise, you would think that this is a simple glass, correct? Yeah. So, as a geoscientist and as a petroleum energy, we are ready to address certain issues. And these issues are related to sustainable development growth of the entire universe. This is where, as a geoscientist, we should focus that in urban city development, geo-health, geohazard, geoenergy, resource, and environment. So from now on, I'll be mainly talking on this geoenergy and resources. Geology understanding is also important because of major earthquakes which affects our daily life. Okay, of looking at, you see at this devastation. Okay, this is a photograph after the great Kedarnath flood that happened, which destroyed the entire thing. And why does it happen? Again, that is linked to the climate change, the way people, they do urbanization, okay, and way the glaciers, they are melting. So everything together, it affects our human intervention, and that too particularly when we are harnessing the hydropower. Okay. So this is where the global, this is a very beautiful graph based on a lot of scientific work, where the global surface temperature was estimated since 60 million years. So there is a continuous record they have measured. And what you can see is that this is somewhere what you have in present day. And you see it is much lower than what it was in Eocene time. And from Eocene, there was a long-term cooling period, okay, which basically absorbed a lot of CO2. Okay? And now when you are going into a warmer phase, that is where your ice are melting, it is creating disturbance. So this study, it is very important. So now what we will do is, we as a geologist, we look at this greenhouse gas in a different way. They are much more beneficial to us when we look at the energy scenario, okay? And out of all this greenhouse gas emission, nearly 11% is given by industry. That is indirect emission. Buildings are second major contributor to indirect way for greenhouse gases, that is 12%. And direct emission involves what is known as electricity and heat production, transportation, industry. Okay, so these are differences between indirect and direct CO2 emission. Now, when we look at petroleum and natural gas, okay, these are mainly derived from what we call it as marine algae, wood, organic matter, everything. And you see this map, how each of this, the lighter one are countries where you don't have, or you have a very negligible oil and gas. The darker shade are those countries with lot of oil and gas. Now this gives a very important aspect, that the countries which are using oil and gas are not those countries which are producing. For example, if you look at India, China, they have a very limited resources. Okay, and the countries which are producing, or they have lot of oil and gas, is Canada, Saudi Arabia, okay, Russia, Venezuela. These are. So this establishes what we call that as energy trade. That is trading of, taking of this. So there is this group of countries, they became the seller and we became the buyer. And this establishes geopolitical scenario and geopolitical trade. So we look at all of this petroleum on a very different scale. We start with the area on this kind of scale, and then we come down to a very smaller scale, how we study. So there is a difference between the study, that is the scaling of our result. Okay, so we train a lot of students, all our students, they have to be trained in field so as to understand what type of variations they are supposed to see. Now training is a very important part of this exercise, of this domain. If you don't train, if you don't look at the outcrop, you won't be able to understand what kind of rock you are looking. Okay, so this domain is where you should have a large amount of data, and which should be capable of making high resolution, reliable 3D model, so that you could very clearly explore. This is something like this. You wanted to build a highways for a city. So you must have a very high resolution 3D data, that from where you can take this road, whether this road is feasible or not, whether you can build very safe bridges on that or not. So if you don't have this data, you don't have this 3D large amount of data, you cannot work. For example, for this figure, you must have data about how traffic is moving, what is the strength of rock, how the mountains are distributed, from where to where traffic is going, what are the amenities you require. So all sort of integration is required for this if you want to do. Your petroleum or energy is also similar way. So we do a lot of geological survey, and we estimate the potential mineral reserve both on a local scale, regional scale, and a national scale. Okay, so this is where we do a lot of surveys. Surveys are simple. You go and check the data and come back. This can be done by foot, by walking along this mountain, or second by drone survey, by seismic survey, well logging survey. So n number of data collection methods are available, which are integrated together here. And then we do certain exploration. Okay, and then we drill and find out whether it contains there. So this is a photograph of gas hydrate exploration, especially in the Mackenzie Delta of Canada, where they have drilled through ice. And on this right hand side, you can see that this is ice, and they're drilling through this to get the hydrate. Hydrate is nothing but the methane gas, which is entrapped in a a crystal, ice crystal. Okay, and this they are doing in a very remote area. So finding energy is not simple. It is not like staying back home and working. It is working with high-grade technology in a very remote area. For example, if you look at this photograph, what are the important technological advancement that you can see? One, for a simple table. So the technology advancement is that all these cabins that you see in the bottom, they are all heated. All humans should be capable of living there. You have all this rig and mechanical equipment which is able to survive in this minus temperature. And then you're drilling through this very hard rock, getting to the resource. So all this technological advancement are very important. They are needed here. And the way we identify this resource in this remote area are through series of data interpolation and data statistical methods, okay, that we use. So we basically map the area on a different scale. We convert those maps into grids, and grids, we have different size of grids, okay, and then we improve our understanding of what it is. So basically, this is also where maths come into the picture. Maths where they would interpolate from one data point to other data point, okay, what is required, okay, whether you have taken that data or not. So this is where interpolation and statistical method that come into picture. And after getting, we do create this kind of 3D images, which is again technologically advanced because you require a lot of very high computing scale, okay, in terms of computers and everything, where you can use this data and make this kind of 3D model, visual models, where they can help you in taking your decision. Okay, suppose I want to drill at this spot, so I have to take this survey, I have to make this model so that my challenges or risk are reduced. Okay, so this is what it requires. Okay, there are different remote sensing techniques which are available to understand the and to link all our aspect, whether it is the rock slide movement or direct linking, everything. So those everything we take together, we make a 3D model for this. This is very easy when we take on the land, but when we do it on offshore, that is in the sea, that is where a lot of advanced technologies are used. By the term advanced technology, what I'm using, it is as simple as that whatever in medical science you're using, the same technologies you're using right now in the oil industry. Whether you take the NMR or MR scan, whatever is there, they are using for the medical, they are using it for understanding these resources. So that is the advanced technological level that we are talking. And just imagine what kind of multidiscipline domains you're having. So yeah, I'll just skip few slides. Yeah. So now comes that how we can find oil and gas. So there is a very famous quotation that oil is first found in a human mind. It simply means that whoever is a geologist, if he have power to think and rationalize where he visualizes oil to be, you can find oil. Okay, and this is a very powerful statement, and we'll see how it works. So like this, when you get trained, you look at different rock types, okay, you understand what kind of variations you are looking. So training and understanding is very important aspect. So that is why we train a lot of students in Kutch itself. Kutch itself is a very unique place where a lot of situations which occur in deep sea, where you're unable to see, they are there, as you can see. Okay, you can see on the outcrop. So that is why Kutch has a very unique geological place. And you can see here, this kind of variations are there where you can actually touch the rock sample, you can study the rock samples which are there. And this kind of rocks, they are there in offshore, which are producing oil and gas. So this type of variations can also occur in subsurface where you don't have any idea. So the idea is, if you have seen this kind of rock, you can visualize it in the subsurface, in the imaging, and you can take better decision. So in a simplistic manner, oil are formed, that is oil or gas are formed when the marine organisms, they die, they get buried in the rock, and this rock experiences temperature and pressure, which converts them into organic matter, into kerosene, and finally to oil or gas. This oil and gas, it is trapped along a rock layer which is porous and permeable, and then you have to drill through that to find that and to remove that. So this is there. Now, from getting this organic matter to converting into oil or gas, it takes millions of years. And this is not very simple. It requires standard temperature and pressure to convert that, and then finally to trap it. So this is what we call as a petroleum system. A petroleum system is a entire system where you should have a source rock. Source rock are those rock which contains organic matter. It should have converted oil and gas. That oil and gas should have gone and traveled through a carrier bed, which are all sedimentary rock, and then finally get trapped. So when you get this entire, all this three component, that is source rock, carrier bed, reservoir rock, trap, and sill, that is 5 component, we call it as a petroleum system. In Kutch Basin, the black color shale, which you can see around Kodki, okay, those are the source rock. The rocks which are there around that Bhuj area are the reservoir rock. So Kutch Basin has a very unique petroleum system. So what we start is, we start with remote sensing. We look at the regional picture. Like for example, this is from Iran, and all these circular things that you see are nothing but folded mountains. And each of this mountain may have potential of each of this mountain has a potential of producing hydrocarbon. So this is how it happens. So for any oil to form, you require what we call it as oil window and a kitchen. Kitchen is that area where the hydrocarbon undergo temperature, especially between 90 degree to 120 degree, and with pressure. That is where the organic matter is converted to kerosene. Kerosene is converted to either oil or gas. So it is as simple as we working in a kitchen. If you're making anything and you don't switch on the gas, you won't make the food, correct? Or if you put the gas on a very high flame, then it would be burnt. So similarly, your kitchen, oil window kitchen, should also be optimum. It is then and then only you can convert that organic matter into kerosene and kerosene into oil. So this is the entire story of this one. So this is something known as Venn-Kervin diagram. This is where chemistry, intense chemistry comes into picture. It is how your long chains of carbon and hydrogen, they are broken, they're converted into this. This is where all this thing happen. So you can see there is an oil window. It starts from 60 degrees centigrade and goes up till 120 or 130 degree. If that is below that, below 60, it is nothing but kerosene. You won't get any oil and gas. It is beyond 120, you get only gas. So even to estimate whether your rock has gone into that, it different scenarios. So what we do is we do follow a very simple scheme. We do global screening, we do basin analysis, which is a very large scale area analysis. Large scale means, just imagine a basin area of 600 kilometer by 400 kilometer. That is the smallest one. And from that, we are going to pinpoint the area where we can drill. Okay. So this takes a lot of understanding. Then we go for prospect generation. Prospect generation is where our statistics will come into picture. Statistics means prediction. Okay. Based on whether you may get oil or gas or not. Okay. And then based on that prediction, you are investing crores of rupees, millions of dollars to just drill one well. This is where it is known as exploratory well. In case you succeed, then you go for developing and then planning how can you recover. But if you don't succeed, those money is waste. And this is where it comes that out of any company drills, one may be successful. So the success rate is 1:10. Okay. So that is why a lot of statistics, lot of background, and lot of multidisciplinary approach is required to make this successful. So in a simplistic process, we do is geologists start the exploration. Okay, they review the data, do the base map, remote sensing data, geological map preparation, everything. Then they do sample analysis. Okay, that is sedimentology, paleontology, palynology, everything. Geophysicist data which is coming up, aeromagnetic, gravity magnetic, seismic survey, all these surveys are done, and there's geoscientists interpret this to give a better model, and these are known as geological model. So out of all this input, what you develop is a geological model which may succeed, which may not succeed. So after every success or unsuccess, you feedback to the input that okay, not work. Okay, and this is how the exploration business done. Now, just to give you a detailed sample, we start from a regional area. We do a lot of seismic study. Now, seismic is where your physics, geophysics, sound wave, all this multidisciplinary approach that comes into picture, and a single wavelet of a seismic is, I think, tens of meter, that's the scale. And what we are expected to find is core from this a very small rock sample. Can you see this key here? That's the scale. And you see this is regional. So there is a lot of scalability involved in this. So you see this is a very regional picture. The vertical depth of this pink and whitish image that you see would be around 3 kilometers depth. And all along this would be around 50 to 70 kilometers. So a 50 kilometer by 3 kilometer snapshot of the crust, you're able to find out with all this seismic wave. And from this, you are interpreting where your oil or gas must be. So what we do, we usually take this and try to integrate with different scale of data. Okay, that is which is known as scalable earth model. We use different models. We use different type of data to integrate. And that is where we generate this kind of three-dimensional contour maps, which can show which are the potential area where you have good reservoir or potential area which are low reservoir. So after this, we go and do exploration. Now, this is again a very important aspect. where the lot of challenges are there. Challenges are there that to install this kind of rigs in offshore, it requires completely different engineering. Okay, you have an entire city which is there, and it has to face all of challenge, that is depth of water, it has to be secure, it has to be safe, and then it has to bring out all this thing. So a lot of different systems are used, a lot of different engineering are involved in this. So just to give you this, these are all the engineering complexities that are there. And this engineering involve mechanical engineer, electrical engineering, chemical engineering, okay, materials engineering, chemistry, geologist, all working in a team to drill out this thing. Lot of pump, electrical cables, joints, weld, there, everything is there which uses this. So basically, when you're looking or finding oil and gas, it is a system where we are integrating all multidisciplinary aspects. And to keep everything cool, we have mud chemistry. We send tons and tons of mud and circulate it so that it can remain cool, the bit which is breaking rock, and then we study this. So there is a lot of technology which is involved here, okay? And what finally we get is this in bottle. Can you see this bottle? It has a blackish color, a brownish color thing. This is what we call it as oil, crude oil. And we get this kind of rock sample which are known as core. Now from this, we have to again give an input. Okay, what is the porosity? What kind of oil it may be having? And for that, we are using thin section and NMR, nuclear magnetic resonance, to understand whether this porosity is there or not. And therefore, we generate a lot of this kind of data point. And this data point we analyze statistically, mathematically to get a better prediction model. Okay. So on this right hand side, what you see are these continuous curves. These are known as well logs. Okay. That's a continuous measurement thing. And from this, you're getting all these data points, thousands and millions of data points you're getting from one site, which you need to analyze. So remember how much computational work you require here. Okay. So the scale what I'm talking is this scale. Your oil and gas is on molecular scale. Your pores in a rock are on pore scale, that is there. You have a rock which is on centimeter scale, and what you are looking in a seismic image, well log, is on kilometer scale. So basically, you are working on all of this aspect as a scientist. So you should be capable of working in kilometer scale as well as nanometer scale. And this is where our technological advances are there, and we should use them. So just to give you a snapshot, okay, on the lower axis, you have width of the size. And you can see when we say of pore, what is the size? The shale and the sandstone, they have the width of their diameter between 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ by scattering or SEM only. You cannot see by naked eye. And all those oil, mercury, all these things are less than that. Okay. So this is the difference that we are looking. Your paraffin wax, that is wax that is there, it is around the nanoscale. Ring structure, asphaltene, those are on this. So there is a lot of scale difference available. Your clay mineral spacing is almost compared to the paraffin. So we develop this kind of prediction model, and then we go for the drilling. This is where lot of simulation, okay, visualization, data science come into picture, because you have so much of data set from different sources, from different parameters. They can be unstructured data or structured data, everything coming to a single point. So you must be very well capable of understanding this. And then we do a lot of study, and this is where we come to the recovery part. And recovery part involves lot of economics also. Okay, this involved risk assessment also, and lot of uncertainty. So these three things are there. There is volumetrics. What is the volume you're looking at? What is the risk involved? And what is the uncertainty? Okay. So when you are able to manage all these things, you're an effective manager, able to capable of removing this. Okay. So in a simplistic way, we do all this technological advancement as a geologist, geophysicist, give data. We then do techno-economic evaluation, and then we calculate reserve, whether we do have sufficient money or the amount of reserve there or not. And then we can take decision whether to explore or not. So a lot of interpersonal communication is involved when you look for this. Lot of data mining is required, lot of algorithm building is required. Okay, so petroleum energy is a very complex system of data collection, exploration and simulation, visualization and analysis, interdisciplinary and knowledge integration. You may be geologist, but you should be able to talk with chemistry, or a chemistry person should be able to talk with physics, or all of them should be able to talk with mathematics. So that is where then you can integrate everything. So this is where it comes. And finally, last two slides, the final aspect is you should also understand the economics aspect of this oil and gas. You imagine so much of money is involved. So any decision that you give, it involves. So this is the cash flow analysis. And you can simply see on this x-axis, y-axis, you have cash positive flow and cash negative. You can see the initial period, you only do expenses. There is no revenue coming to you. After putting money for almost 7 to 8 years, that is where you start getting your cash in. And after 3-4 years of that, you may start getting profit. Okay, so a lot of economics is involved. So even a simple mistake on your part in estimation will jeopardize this profit scenario. And that is why certain skill and attitudes are required when you want to integrate all this multidisciplinary aspect. This would be my last slide. So please remember this. Okay, always ask what if. Okay, exploration requires creative mind. So you have to ask yourself, what if? Surface geology is about prediction from limited data. So you have to be uncomfortable with that. Okay, you have to make accurate prediction in geological context is vital. Look at the big picture. That is where integration of all this aspect of chemistry, mathematics, everything is important. Be very aware of the scale. Okay, because as I said, you'll be working from a nano scale to kilometer scale. Analogs are vital. Okay, going to a field, understanding analogs, understanding this one is, be aware of your own biases. Okay, software will help you make model, but understand what this model are. You must know what is giving. Don't work in silos. Don't work. You should always, as a PhD student, you should always integrate. Geological age, you should know. Okay, and stay connected to rock. Go out in field and do a better prediction. So I think I will stop here. We can take some few questions if you want. Thank you.
Thank you so much, sir, for the lecture. I hope everyone understood and gained a lot of knowledge from this. Thank you so much, sir.
Yeah. Okay. If anyone has question, then yeah. Yes, Vivek Chauhan.
Good afternoon, sir.
Yeah, good afternoon.
Sir, in your slides, you have mentioned that if we are going near the equator, then there is high diversity, and if we are going towards the pole, the diversity
Yes.
decreases.
Yes.
Sir, can you explain how it is happening?
Yes. See, what happens is animal, they are not very comfortable with colder climate. If you see the mammal distribution only, near equator, there are so many. Can you find an elephant in near the polar side? Very rarely. Okay. So if you look at the diversity also, in case of the coral and everything, it is more on the equator side rather than the polar side. So that is where the latitudinal gradient in diversity. This is a very good concept in paleoecology also, in geology, paleontology. Yeah, Vivek. Yeah.
Okay, sir.
Okay. Yeah.
Thank you, sir.
Thank you. No.
Sir, I think it is clear with everyone else also. So we'll end the meet here if that is fine with you.
Sure. Thank you, everyone.
Okay.
All the best. Yeah.
Thank you so much, sir. Thank you.
Yeah.
इसके बाद का जो लेक्चर है वो 2:30 से है, तो बाय 2 o'clock 2:15 आपको उसका लिंक शेयर कर देंगे. अभी आप लोग ये मीटिंग लीव कर सकते हैं. थैंक यू.